Hello everyone, it's August the 10th. Wait, I thought it's the easy one today. I was wrong. Did it change? Then become a hard one. Damn, that's different. Alright, minimal number of days to disconnect island. You are given m by n binary grid where 1 represents land and 0 represents water. An island is a maximum 4 directionally horizontal vertical connected group of ones. The grid is set to be connected if we have exactly one island. Otherwise, it's disconnected. In one day, you're allowed to change any single island right into a water. So the minimum number of days to disconnect the grid. Hmm. Minimum number of days to disconnect island. So basically, we want to turn some ones into zeros, right? Such that we have two separate, right? We have two separate two separate groups. If I union find to put them all together, okay? Yeah, we get all of these together, and then we can say, tell me how many unique ones are there. Okay. And then we say we take away one. There are many. There are a lot of different combinations that you can remove, right? And how do you even remove one? If you do union find, we only have a union. Remove. I don't know how to remove. Or, on the other hand, you can try to find what's the maximum number of land that you include and can maintain it still two separate islands, right? We should have a beautiful, gorgeous dream, lovely, wonderful sleep. Wake up tomorrow feeling amazing and full of energy. Okay, there's some other phone calls. Smell wonderful. Ay, ay, ay. They must be very grateful. Yeah, definitely there will be tons of YouTube channels. You can try it first before going to an actual island. Oh, okay, nice. So it must be. No. Alright, got it. It's heavy. Alright, let's get back to this. Yeah, so I was thinking maybe we can say how many. So we have let's say the total ones, right? We know. And then we try to see what's the max number of ones we can include, right? That maintains two separate regions. then we can say however number, right? Because I'm thinking about binary search in this case. Yeah, let's say if we have like 100 ones, and then we say, okay, how about 50? And we need to figure out a way to include 50 such that there's still included by 50, but they're still two separate. How do we do that? Well, what we can do is we start from someone and then do traverse everything. Traverse everything. Like if initially then it's not connected, then we need to remove 0, right? So it only happens if initially it is connected. Initially it is connected. Okay. Then it's like just a minimum number of edges to remove in order to break one connected graph into two separate graphs. I feel there is an algorithm for this, but I don't know what it is. Or maybe you can find, kind of get a shape of it, right? And we can get a shape of it if we check to find all the cells that's connected to the outside, right? And all the cells, yeah, so all the cells that's connected to the outside and all the cells that's in the inside. So typically, if you remove cells on the outside, that usually will not work, right? Because you can have cells that's surrounded by water in 3 areas, right? So things like, just things stuck out, like this thing. You have 3 sides connect to water. So this one you can always remove. It will not mean anything. So what it will mean things is the one that's connected to water with 2 sides, right? Connect to water with 2 sides. if you have connected to water with only one side, once you remove it, then you just create two that connects to water with three sides. So yeah, I mean, it might work, it might not work. Like I'm thinking about if I have a block like this, it is to take away. Yeah, it doesn't matter how you take away, that's the only way. Three, you have to take out three. But then you have something that's kind of in the center. But if you have a blob, then you want to break it up, right, into two. Then you definitely need to like create something to slash it. So maybe you can find the ones in the middle. I don't know. It's a thing. The shape can be really weird, right? The shape can be weird, but usually diagonal wise, it's easier to break. I feel like I'm doing it the wrong way because you're analyzing it. Diagonal. You pick the top left. Doesn't matter which one it is. You pick the top left, and then yeah, you pick something. Then you don't. You pick something, right? You pick something. We can just say a top left, because the shape is whatever the shape it is, right? Then you just pick top left, and then you do not do these two. Then you can fill whatever the rest. It's always going to be two, right? I just realized it's always going to be two, because if you remove this, now these are two islands. So the minimum number to remove is 2. So now the question is just to find if anyone is 1. For example, this is 1. We can always find 2. So we just need to make sure. We will remove 1 and see if they're still. Yeah, we're gonna do remove 1, any 1, if they're good. If we, by removing 1, we can, avoid this from becoming a fully connected, then the answer is 1, right? If removing 1 cannot work, then we have to remove 2. Sounds about right to me. Now the question is, I'll union find this for sure. I'll union find this. Every time you union, can we just count? Yeah. You are union, and then okay, the question is, we'll need to get the yeah, you remove 2 definitely, no matter what situation, you remove 2 will definitely work. So to begin with, we will first produce the initial investigation to see if it's a 0. Okay, and then if it's not a 0, like everybody's connected, then you're gonna set them 1 by 1. Okay, set them 1 by 1. Then you're also gonna have, you can have a list of positions. So each one you'll set them 1 by 1, and you'll run it again, and you check what is the number of islands. If by removing 1 you can get it, the answer is 1. If it doesn't work, just return 2. By removing 1, you will have 2. Well, it depends. If we only have 1 island, or when we have no island, either 1 island or no island. How do we do that? If we have no island, so we'll count it first. Well, we don't count it first. Do the original. But you don't know the number of islands. So I need to check the number of islands. If it's 0, then you turn 0. If it's 1, yeah, that's actually a good question. If it's 1, what do you return? I think you return 1. If we only have 1, you will return 1, because that one has to be removed. Right, you return 1. If I have 2, And if they're not connected, then you will return 0. I think this is probably a 0. If it's 0, that will be 0. Yes. Okay, then give this a shot. Parent rank Okay, so we also need a int number of regions. Should be void, right? No, int. Parent x. Okay, this is fine. I should call it this. Okay, if px equal to py, turn false. Alright, which means they're already part of it. Otherwise, rank, yes. Parent. Okay, and then we can say this dot num regions minus minus. Okay. Okay, so I have a grid, right? So we need to first find out list of int ones I need to know if they are originally connected, right? That's what I want to know. So We're going to pass connected number of regions. Okay, so private int num regions. We'll pass the grid in, and then that's it. Okay, have grid. Okay. So now for this we can say DSU. Ooh. Number ones. Okay. Then what we're gonna do is just go through them. Right. And then yeah, we need a way to index them. Shoot. How to index them? Well, actually, it doesn't matter. I know the number of ones. I know the grid. So I know. Well, actually, no. That's not right. We want to know number of ones. How many regions, right, are within the number of ones? So I need a list of ones. Yeah, I need a list of ones. Ones, and we need something to remove. Not considered. Oh, if I can just remove it from this. Where is changes value? Hold a second. So we look for directions. So we get that. Yeah. List of ones. So we go through the list of one. We get the first one. We look for directions. Right. If they are a one, we will, merge with them. So what do you mean by merge with them? You don't know you don't know their indices. Jesus. How about you mark it with a value? Index. You mark it with index inside a grid. So you just do like one indexed. You go with a 1, 2, 3, 4, blah, 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 whatever. Right? And then after index them, you turn into 0, right? You turn that one into 0. Okay, turn that one to 0. And here you just go straight, this, go for direction. And then you union them. Okay, so then I don't need this. But I do need num1s. Okay, this is b plus 1 because, you know, it's a 1 indexed. And then we just say for int I equal to 0, I is smaller than grid. Yeah, probably like m. Okay. If grid j is not equal to 0, okay, we check its for directions. Okay, for and also larger than 0. TSU dot union. Grid, the ones have already been indexed. Okay, so with basics, we'll go through everyone. Yeah, I guess it doesn't matter. We just go through everyone. Go for directions. Right, go for directions, and then we just start union them. And once we're done, num region, so we can just return dsu dot num regions. Okay, we still need that. Okay. If grid ij equal to 1 larger than 0. Okay, it's equal to 1, fine. Then grid ij to index plus plus, right, equal to index plus plus, and then 1 dot add. Right, we'll go through this. So at the end, we can say if 1 dot size is equal to 0, turn 0. If 1's size to 1, turn 1. Okay, so we can just say equal to 0 or equal to 1, turn 1's the size. Right, and then try to remove just one island and see if we can split. Now, if we can split into 2. Oh, okay. One more. Examine if the original islands already have been split. So say if this dot non-regions grid number of 1's is 1 dot size, right, is larger than 1, then return 0. Okay, say 4 1 1's grid right, and then we'll count the region. We remove that basically, then we count to see if we have 2 regions, right, and then we say if this dot num regions grid 1's size minus 1, if this is larger than 1, turn 1. Otherwise, grid. Oh, we need a temp. So if none of them works, right? Time to return 2. Break the island by removing just a 1 cell. We can always break the island by 2 cells. Yeah, no matter how, you can do it by 2. Because you can always find the top left, top right corner, and then you can just break 1 or break 2, and then it will work. Okay, let's give this a shot. Okay, this actually I'm not very certain, but we'll see. Okay, was not right. I think the second part is easier to do. Let's see what happens. Num regions. Alright, grid. Numbers 2. Okay, let's not do this. Let's just count at the end. Yeah, let's just count at the end. Wait, hold a second. Hold a second. I think you should be right. Initials 2, right? Non-region initials 2. And then we do 1 union, so minus of region will be 1. And I go to the second one. We try to do it again. And I union them again because they already unioned. So I don't do it. Because I already unioned. So I don't do it. Huh? Let's see if the first one is correct. Shoot. Standard output is 2. This is not right. Hold on. Let's take a look. Out the print line. And then 1 is 2. Okay, that's good. And then wait, hold a second. Grid. Yeah, maybe we need to debug this. 0, 0, 0, 1. Let's see if the grid is correct. Grid should be 1 and 2. Yes, grid is correct. Right, grid is correct. But why the num regions? Because when you union. Okay, so if it's larger than 0, we go through 4 directions. If it's good, we'll do the union. Let's put this in console.log. Okay, let's just take a look. Should be called twice. 2 and 2. Huh? How? I don't understand. I unioned them already. Oh, it is. Because non-region, I do n. It show -1. Right? It show -1 because when I input, I got all of them. So if I do non-regions, it shall be this one -1. Return num regions need to -1 because we do not consider the region, the union, the region formed by index 0. All right. This looks promising. Huh. Four. It shouldn't be. Darn. Because the index doesn't change. Holy crap. Yep, the index doesn't change. Now we have a problem. Yeah. Hold on. I know. Num ones. Yeah, we cannot do that. Num ones is a set. Then we have reduce 1. Okay, yeah. There are some stuff we have to do. Damn it. if DSU num regions no, don't do it here. Do it here. Num region need to -1 to remove the formed by index 0. Unrelated. Yeah. Right. There's so grid DSU, go to this bucket DSU grid. Right. So this one will get. Then what we need to know is how many regions. So we can say if DSU.num regions -1 -2 right, -2 because not counting the region formed by index 0 and index temp. Okay, let's try this. So let's throw some curved balls to it. For example, we do this. Okay, let's throw a few curved balls. All right. This solution is based on the idea that given any grid, as long as there are at least 2 islands, we can always remove 2 islands to break the 2 cells to break the islands, to disconnect, right? Disconnect the island. Thus, the question becomes whether it is possible to remove 0 or 1 cell to disconnect the island. If the island already is disconnected, we remove 0 cell. If by removing each cell and re-examine the island situation, we can find one such cell that when it is removed, the island becomes disconnected. We return 1. Otherwise, we always return 2. OMN times I'll say OM squared, N squared, because get DSU is, this is M times N. This one's also M times N, so it's gonna be this, and you probably need to say times union find. Okay. Let's see. If it's wrong, then I have no ability to get it right. Okay, so that's that. And very luckily, it was correct. Now, for this, we have to check the solution. Flood fill Tarjans. This is the one, Tarjans. Yeah, is flood fill. Maybe, yeah, we can use this instead of union find. We can just find the first one. And then we know that it's good, right? Yeah, BFS, DFS, doesn't matter. We just visit all the cells, and after we visit all the cells, we check how many cells we visited, right? Yeah, we can do that. Yes, you can always do this, you can always do this. Okay, we need this Tarjan's algorithm. OMN. Ooh. Alright, I'll save Tarjan some other time. Wow, it just build this up. Eventually, it's gonna be so many. I don't even want to solve any one of them. I still haven't even done this, man. Now I have a new one. But anyway, that will be it for today. We did solve it, but it's, it's not the best. I'll see you guys tomorrow.